Hey everyone. Okay, so thank you very much for taking the time to join me today. I think this will be a very interesting lecture for some of you. Okay, so today we're going to be talking about mechanism design. So mechanism design is probably the coolest area of study, maybe the coolest thing that people can engineer that you might never have heard of, I would say. It sounds a little bit plain on the outside, but really what it is how to program humans for dummies. Um, this is essentially the art and science of building incentive systems. This was a kind of fairly obscure part of economics for a very long time until blockchains came along, and then suddenly the learnings that they'd had in this field in economics became extremely relevant when we were considering essentially how decentralized systems work with adversarial participants. So how you can build incentives into our programs such that all of the participants are incentivized selfishly to perform the right kind of activity. So the goal is to write applications that essentially execute on crowds of humans reaching an intended goal. You can think of this as if you're writing a program for a new type of machine, and the machine is a crowd of humans. But more than that, the goal is to be ethical. I would say that most of the things we're going to talk about here fall into largely unregulated areas of life and society. And I don't think that the law has caught up yet with the potential effect and power of these things. So while we're going to be talking about the theory here and go through some examples, we're then going to talk pretty heavily about the ethics involved in this area of study, as well as then going back to how you can build these things in the wild while being careful about those ethical points. It's extremely, extremely important, I would say. We need to, frankly, I think the power of this thing, once you see it in practice in the real world, the power of what this allows you to do is so strong. Yeah, we need to make sure as an industry that we are self-regulating until such a time where society comes to some sort of consensus around how these things should work. So, without further ado, okay, the theory. So first I want to take you through what you could think of as a kind of frame for looking at problems in life. And then from that frame, we will develop a method of creating mechanisms which incentivize people to act in the way that we need them to for whatever project or thing that we're building. So likely in our case, this is going to be people taking part in profit-sharing communities or decentralized networks of some kind or other. So incentivizing people to interact with your application in the way that you want to, while also watching out for those ethical, traps. So the first part of this frame of looking at the world is to understand that each individual person is unique and their actions cannot be predicted. However, crowds of humans generally act predictably. This is the driving force behind the whole thing. There's no real way to predict with a high enough degree of accuracy how a single individual will respond to an incentive mechanism that you've created. But when you put large enough numbers of people exposed to the mechanism, then you can be fairly sure and you can mathematically calculate what the likely outcomes, not just likely, but what the outcomes of that mechanism will be. So first, we've got to understand that unlike in the world of computers where we're used to programming things, in the world of humans, the machine is working towards goals, and these are created by basic instincts. So we have basic primitive goals that we need to all reach on a day-to-day basis: eating, sleeping, hydrating, procreating, protecting self and family. In fact, actually, this has been elegantly formalized into Maslow's hierarchy. So most of them that I was speaking about are at the bottom physiological need level. But on top of that, we also have safety needs, love and belonging, self-esteem, self-actualization. And as we go up the pyramid, I would say that these become sort of, frankly, fuzzier and actually arguably less interesting from a mechanism design perspective, because they're more tailored to the individual, less easy to reason about, essentially. But these basic ones, like we all need air, water, food, shelter, sleep, clothing, reproduction, they're all very, very predictable and very, very strong in in almost every individual in the crowd. So these are the basic goals in life. Our bodies create rewards and punishments when we interact with these goals. So when we go towards the goal and when we move away from the goal, our bodies will create incentives. They will create rewards and punishments if we make progress or move away from progress towards these goals. Brains are also planning machines. So they take this problem of like, okay, I've got a human, I am where I am right now, and I need to get to this goal that I've defined, or rather really my body has sort of surfaced for me. Like I'm hungry, for example. And now I start to intuitively or just instinctively make a plan that's going to take me from where I am to that goal. So this is a basic pattern of life, all life, you could even argue. It's humans making plans to get towards goals. But in order to achieve goals, because the world is so unbelievably complex, we have to create sub-goals, which enable incremental progress. And this is because like the idea of making a plan from like, I don't know, where I am now to some blissful, idyllic life that I want for myself, some, abundance of food, water, whatever it happens to be, clothing, some idealized view of the world. It's not possible to make a plan that is the entire step at once because it's far too complicated. So instead, what our brains, again, instinctively, naturally do is they break down the process into sub-goals. And this allows us to incrementally get towards the larger goals. So it's just like this. You have a human, they have a sub-goal, and they make a plan, and they go towards it, and then they make another plan to get towards the goal. And this process can obviously have as many steps as you want in between. So then we can look back at like our goal when we're for this lecture here today. Like, what exactly is the goal? We said at the beginning that it was this, but you could actually argue, no, everyone here today is here for some reason, but I doubt that this is precisely the end goal. Actually, this is most likely just a sub-goal on the way to something else. So perhaps you could take a moment to consider what exactly is it that this goal that we're talking about, this sub-goal on the way to, where is it exactly that you want to go? Just curious. All right. So one of the things we can understand about this system is that money and social status are almost universally applicable sub-goals on the way to the main goals that we have in life, the base goals, you could call them. When I want food, one of the ways that I know to get food, in fact, the easiest way by a long way, is to get money first, then I can go buy food. Now I have food. So it's like a multi-step process. First goal is money. Second goal is buying the food, so planning, getting to the shop. Third goal, eating the food. And there we go. Now I'm at my, now I've met my base instinctive goal. This is pretty interesting from a mechanism design point of view, and I'd say this is where things really kick off, because now you can realize that any mechanism you can build that can output money or social status will incentivize people to take part on the way to whatever major goal it is. And that's really powerful, actually, because this is the unifier. So you don't need to know or worry about what the goal, the base goal that the human is attempting to get to is. You just know that the output of money will help them get there one way or another, almost certainly. If you look back at Maslow's hierarchy, you see the self-actualization and this type of stuff. Obviously, money isn't going to help, but this is why I was saying it's less interesting to us, because it's fuzzier, harder to reason about. But now you take a crowd of humans, and they're all hungry, or they want to sleep, they want clothing, whatever it is. And you can be confident that basically every single person in that crowd will be incentivized by money or social status as a reward. And in general, in mechanism design, we're interested in the monetary side of it. But actually, we will cover a couple of times where social status can also be used as a reward in a mechanism. So your programs are incentive designs that insert themselves as sub-goals on the path towards the general goal. That is, they insert themselves basically as a mechanism which outputs money, which is a sub-goal on the way to the base goal. Just like this. And now, here's the crucial point. By designing economic games appropriately, we can force or incentivize selfish humans to exhibit useful behaviors. And there we go. This is Mechanism Design 101 in a single slide, I would say. You have a human, they're incentivized to take part in a mechanism so that they get money or social rewards as an outcome on their way to a goal. But by taking part in the mechanism, they have produced a useful byproduct for you, the mechanism designer, hopefully in an ethically appropriate way. Okay, example number one, bottle pickup. many cities around the world now run a program where you can pick up a bottle from the street and you can return it to a recycling point, and you can be given 20 to 30 cents in cash as a reward. So the reward here is obviously money. The mechanism is picking up the bottles, taking them to the recycling centers, and the useful byproduct is that the streets are clean, as well as actually it gives a base job for people that don't have another job in society. So it has this sort of multi-pronged useful outcome. But you can see very clearly it's a simple mechanism design. However, highlighting one of the dangers that we can talk about in a little while, unfortunately, one of the things this also incentivizes people to do sometimes is to route through bins to get bottles that have already been, appropriately, not thrown on the street, but appropriately put into a receptacle, to route through them, pick them out, and then return them for a reward. This is obviously a kind of inhumane thing to incentivize. We really don't want to be paying people deliberately to route through bins as a job. That's an awful thing to do. And yet it's an unexpected consequence of the mechanism design that was proposed and put into action. So this just highlights really how careful we need to be while modeling these things, so that we don't have unintended consequences that are, inhumane in effect, essentially. But another example. So when the scooter craze started about 2 or 3 years ago, no, I guess maybe 4 years ago now, there was this problem. You've got these shared scooters. They start in like useful positions in the city in the morning where people live, tend to be where people live. And they're all recharged, so they have a full charge. Okay, but by like midday or mid-afternoon, they're all in complete disarray. They're all over the city in the wrong places. They're really clustered together, which is super unhelpful. And also they're all out of charge. So the scooter companies realized, like, V1 of the system is, okay, get a van, drive the van around, pick up the scooters, replace the batteries, and then move them to the right place. But that's not actually very efficient. Like, that's, for one, you have to solve the traveling salesman problem, because you have this single vehicle that has to visit all the different points that might be useful, both picking up and dropping off scooters. And number two, it's just like, it's very hard to plan this centrally plan this. But then V2 of the system came along, which was like, oh, okay, well, you can get the local population, essentially. If you build a mechanism that says, look, you go around, you pick up these bird scooters, you move them to the right place, you put new batteries in them, or you recharge the batteries, and we will pay you a small reward. Then this is very efficient, because now you have this decentralized crowd of people trying to find the most efficient way to achieve this task for you. And that's another pitfall. You really, through mechanism design, incentivize the most efficient way of working or of solving a problem to be the thing that people do. So arguably what this guy is doing here is not very safe, is it really? He's got an awful lot of scooters there. But nonetheless, you can build these incentive mechanisms that incentivize people to solve complex problems for you. And again, useful outcome is the scooters are all in the right place and they're fully charged. The mechanism is this sort of, arguably a program that they built that runs on the crowd. And yes, the outcome of that for the participants is money. And obviously, this guy, I don't think he lives and dreams about solving this problem of the scooters. He looks to me like he's very excited to eat some steak later or something like this. He's thinking about getting the money to go and use it to solve one of his other problems, one of his goals. Okay, so these are all systems that have financial reward, but here's one that doesn't. This is a Bittorrent client. Bittorrent uses a very interesting mechanism design called optimistic tit for tat. So the basic principle is, I give data to you and you give data to me. Or rather, if you give data to me, I will give data to you. And then occasionally, this is the optimistic component, I will just give data to people at random if they ask me for it. And the Nash equilibrium, so where this game reaches a fixed point, so where it tends towards, if you play it out over a long number, a large number of people over a long period of time, is that everybody is sharing data with everybody else. This is a really powerful system, actually. And so you're creating a social reward. It's actually this reputation that allows you to download data from someone is the reward of the mechanism itself. But this system is very simple, and it was responsible at one point for transferring around 30 to 35% of the world's internet traffic. With and if you think about that, that's actually like a very large cost. To rent that much bandwidth would be, a staggering cost. Yet it was made by this very simple mechanism design, which really, I think, proves the power of the system. Okay, final example, Bitcoin. Obviously, I assume many of us know how Bitcoin mining works. Basic principle is that you have a certain difficulty, and then you have to solve a mathematical problem that satisfies that difficulty. So you take the block data segment that you're trying to mine, basically the header of the block that you're trying to create. You guess a random number, you hash it, you see whether that output is greater than or less than the difficulty. And what this system does, I mean, it's very, very simple at its core, but what this system does is that it incentivizes people to compete with one another to put more compute resources into mining Bitcoins up until the point, and this is the really elegant part, and of course that's providing what you could call economic security to the network. But it's very elegant in that it goes to the point at which the profit margin essentially dropped to zero. And then it will stop. And you'll find with all cryptocurrency mining systems, there's essentially this process that people join the mechanism and they execute it until such a point as the profit margin has almost reached the level where it's just not possible, or it's just not worth their being involved. What's really interesting about this two components. What's really interesting about this from an economic side is that actually now, as a task fulfillment system, what you've done is found the optimum pricing, the most efficient pricing for the task that you're asking the people to do. And this is a motif that can be used repeatedly in many different areas, and we'll look a little bit later at how you can deploy it in practice. But there's another side of this, which is also quite dangerous and negative, at least for community building in decentralized networks, which is actually that if you are, if you closely study mining communities in crypto, you'll find that there's quite a lot of negativity relative to other communities or other parts of the community in cryptocurrency networks. And one of the reasons for this is because everybody is at some point always going to be disappointed. Like, there will always be a set of people who are essentially not finding it profitable to mine the token, and so turn off their machines. And so the value expended on mining the thing will always oscillate and fluctuate just around the actual value that is being emitted by the network at any one point in time. And that means that when it goes up a little bit past the level of profitability, then actually everybody is doing poorly until such a time as people turn off their machines, and then the profitability dips back into the positive. And you'll oscillate around this point essentially indefinitely. But it certainly doesn't make for good community dynamics. People are very upset about this sometimes. With fair reason. It's a difficult system in some sense. Okay, so that's the basics of how to think about the process of building mechanisms and what a few of them look like in practice. We're going to get into some much more concrete examples later that I think you can go and deploy in practice. But first, we should really talk about the ethics of this. So an example to start with. This is Maurice Duplessis, who was a governor in Canada during, I think, the 30s, this was, or late 20s. And Maurice had realized that the federal government pays him, I think it was $2 or $3 for each child in the sort of federally provided housing, for children without parents, unfortunately. And he also received $7 for people in psychiatric care per day. These values were, and he noticed, well, he had some sort of fiscal incentives to sort his balance sheet, and he noticed that if he essentially reassigned some of the children from their housing to be in psychiatric wards, so if he gave them essentially false illnesses, then he would receive or actually not just him, but his province would receive 2 or 3 times as much reward from the federal government, which isn't. It's a hideously awful thing to do. Like, if I remember correctly, tens of thousands of children were falsely diagnosed with mental illnesses as a result of this guy's actions. And of course, the Canadian government eventually changed the system because they realized that there was this enormous perverse incentive inside it, essentially. But this is just one example of how your incentive systems, if you do not design them carefully enough, if you don't really work on modeling them sufficiently, you'll find that they have very negative side effects when you're doing something that appears to be actually quite good. So, providing funding for children without shelter from their parents, and also providing funding for people with psychiatric illnesses. You'd think this was a good thing to do, but if you're not careful about the way the mechanism is designed, you can have really terrible consequences on the world. But at least in this case, Maurice, or rather the incentive system that Maurice was interacting with, could be turned off, right? This was a centralized system managed by the government. They realized there was a problem. They fixed it. They can't go back in time and reverse the damage that was done. But, they can at least stop more damage happening in the future, which until decentralized networks came along, would be hard to think that that was like a really positive thing that we'd even have to worry about. But with decentralized protocols, they enforce games that cannot be terminated or updated, potentially rendering errors fatal. So here is one that I would argue is a pretty flawed mechanism design. So for what it's worth, I think Bitcoin is absolutely incredible. It's probably the most powerful invention since the internet, I would say, if not. Yeah, I think that's about the right level. It makes currency possible in a peer-to-peer fashion with no centralized issuer. And that is just monumental, right? But I don't need to tell you guys that. But there is this fundamental flaw with Bitcoin. Back in, I think it was 2011, 2012, Satoshi Nakamoto commits something with this vague Git log that said, add 1 megabyte block size limit. No other justification given. And over time, of course, so back then, 1 megabyte was a lot. Before that, for what it's worth, there was no block size limit. You could fit as many transactions as you wanted into Bitcoin, and it was live. And I think this was added in response to someone spamming the network for the first time. So added a quick fix to stop the spam attack. Okay, fine. But now we find ourselves in 2017 when cryptocurrency is having its first major push of adoption, and the energy used by the network is sort of skyrocketing. It's really becoming enormous. And the number of transactions that the system is able to process has essentially stagnated. Everybody knows that Bitcoin can process more than 1 megabyte worth of transactions every 10 minutes. That stands to reason. And Satoshi, I don't think, ever intended for this to become the hard limit forever. But the problem is that the game is decentralized. Nobody has the authority to update it anymore. And so no one can come to any true consensus around what the new block size limit should be. And so, of course, we saw all these forks happening with the network. This is very negative, not least because at this point in time, it was using as much energy as Bulgaria. And the amount of transactions that were processed by the network obviously doesn't scale with the amount of energy usage. So the higher the value of Bitcoin gets, the more energy it consumes, which is a sort of, in some ways, it's a terrible virus. And it doesn't have to be this way. You can do other forms of proof of work, like Arweave transfers some of that value expenditure to hard drives, for example. But many other systems do many other mechanisms. It just happens to be that Bitcoin has chosen this one, and nobody in the entire world has the authority to turn it off or to update it, which is obviously very dangerous potentially. So I think that's only the start, though. I think these two factors combined with human error could lead to almost world-endingly bad effects. and I would argue that one of those avenues for potential disaster comes from the merging of artificial general intelligence and blockchains. So in AGI, which when I first made this talk and I gave it for the crypto startup school at Andreessen Horowitz, like a year and a half ago or something. No, just about a year ago, actually. We'd just seen GPT-2, which I don't know if you've played with it, but it's monumentally intelligent relative to the prior, chatbots, essentially, that you could speak to previously. I think it's very clearly a quantum leap in ability there. And it does things that look generally intelligent. Like you can get it to draw for you, for example. You can also get it to sum numbers. It seems to have learned some basic form of math. I'm not saying it's AGI yet, but it's getting pretty close. And then, of course, we saw GPT-3 come out not a few months ago, which again was just an enormous leap in the efficiency and the power of these systems. Okay, fine. So it looks like artificial general intelligence is, and I know this is famous last words by many previous people, but it looks like it's around the corner-ish. Next few years, we should probably see something that gets hard to argue is not AGI. Now, at the same time, we have this growth in interest in mechanism design and essentially decentralized networks that can't be turned off or updated. You could argue that essentially these networks give sovereignty to programs. They make the program exist unto itself. Bitcoin does not answer to anyone. It is just a kind of, in some sense, a virus that is out there, that runs on people, that executes on the crowd, if you will. And nobody can update it, no one can turn it off. You can very clearly see, well, if someone has the not so bright idea of putting an AGI inside this system, well, now you have sovereign artificial intelligence that is generally intelligent. Sovereign AGI, I think, is not necessarily a bad thing, but it's something we need to be really, really sure we understand the effects of before we turn on. And the problem, of course, with this area is like basically anyone can do this stuff. Anyone can hack this stuff together, and you don't need a lab. You just need a laptop. I think that's a major danger. And of course, what the goals of that sovereign artificial general intelligence would be are not clear yet. That I think would be the crux of whether this turns out to be a terrible, terrible thing or not. But you can very plausibly see how that future might look and what the concern there might be. In fact, this paper is quite interesting. It was attempting to argue that somebody who's already been experimenting with this a little bit as well, or already, using cellular automaton inside Bitcoin. But that's a conversation for another day, perhaps. Okay, so look, I can't give you clear advice on what the ethical framework should be here, because frankly that's not my place to do so. But I can suggest a simple checklist that you can use when you're designing any mechanism to check that what you're doing is not going to be monumentally negative. First, check that the mechanism is fair to the people that are participating in it. Is the reward they're receiving actually fair for the work that they're giving? Are the participants informed? Do they understand what is happening to them? Is this a conscious choice that they're making to take part in the mechanism that you have designed or not? And then finally, and this is the one that's frankly harder to adjudicate for oneself, I would say, are third parties negatively affected by the mechanism that you're building? And I would say that the Bitcoin example, to pick just one, the environment is very clearly negatively affected by this. So it doesn't pass that third test. But of course, you could argue in the case of the bottle bank or bottle pickup mechanism, that arguably doesn't pass number one. And maybe there's another way you can look at this, which is like, well, okay, do the positives outweigh the negatives as well? It's very complicated, but these are at least three areas that you could think about for yourself while you're designing the mechanisms that would ensure that you kind of stay on track a little bit. Okay, so now we've looked at the basics of building mechanism designs from a theoretical perspective, the ethics associated with it. We can also look at how to actually do this in practice. So what are the steps? I would say there's essentially 5 steps involved in the process. First, you have to choose the byproduct that you want. Then you have to choose a reward, and then you have to choose a reward function. So how you're going to distribute that reward amongst the participants in your game that you're building, essentially. Then you have to build it. And there are actually tools in the Arweave ecosystem that make this extremely easy. And then the part that most people often forget, distribute it. How do you get people to know that this mechanism exists in the world, and then to start taking action and taking part in it? So we're going to use the example of Arweave, where essentially at the end of last year, Phil was starting to think about ways that he can get more people exposed to what Arweave is and get them staked into the success of the program. So he decided that the byproduct he wanted when he was building his mechanism was staked Arweave users, people that are initiated, like taking part, and also feel they have a small amount of ownership of it. So the natural reward that you could give them is Arweave tokens. And of course, this is a kind of sub-reward on the way to money, which is on the way to the meta reward. Yeah, this is obviously not precisely money, but it's pretty close. It's actually a sub-goal along the way, you could argue. And from Phil's perspective, this is nice because it increases the staked component of people's relationship with Arweave. So then he chose a reward function, and we're just going to get into this in a bit. Like, you don't have to think about this too much right now. We'll go through it like piece by piece in just a few slides. Build it. Well, there's a tool called Team, which was built by the Verto team, which is essentially created to make this as easy as possible. It's a way of encoding your reward function and sending profit sharing tokens if that is your chosen reward. Although I think for most profit sharing communities, the chosen reward for number 2 will be profit sharing tokens. So this works well for that. And then just allows you to embed number 3 in it, essentially, and code that up in a really simple way. And the distribution, Phil did a great job with this. He put it on his Twitter, on his Medium for Arweave, and on the Arweave Discord, as well as the Arweave developer Discord. You know, it really spread it around the Arweave community and beyond, actually. Okay, so when you have this, you can think back to our initial model of what a mechanism design looks like in the world. You have your human. They're exposed to this astatine-based mechanism design that you've created. And the outcome is Arweave initiation. So that's the useful byproduct. The goal that they're pursuing is essentially the sub-goal we're interested of that is money. And who knows what their real goal is. And the sub-goal that we're producing on the way to that sub-goal is Arweave tokens. So we give them Arweave tokens. Eventually, they can be converted for money, and that gets them close to their personal goals. It's a very effective system. Phil found that after he was running this for a little while, he was responsible for like, I think 15 to 30%, can't quite remember where, of all of the data being stored in the Arweave network. People really got excited about it and got involved. And as a result, even now the program has ended, there's an awful lot of usage of Arweave because they're initiated users that know that it solves their problem very well. Not only that, they're actually staked into the success of Arweave because they own some tokens. And so they start to tell other people about Arweave. And then it sort of spreads on its own. Yeah, so that's a basic version of this. I would recommend that basically everyone starting a profit-sharing community would consider something along these lines. It's a very effective way of getting the word out about your community without having to invest very, very heavily into marketing. But you can take it one step further if you really want to. And this is what you could call the rVerify mechanism loop. So rVerify is a project that attempts to build a blue tick for the PermaWeb. It's, in technical terms, it's Sybil resistance for the decentralized web. And what that means is that it's essentially a way of stopping people spinning up many accounts that are not either run by humans at all or are run by the same human. So bot armies that report to a single person and look like they're many people to the observer. On Twitter, for example, you see this often, but are in fact just a single person. And the way that this works is that you essentially have a web of trust. So I trust Phil from Arweave, I trust Tate, for example, and I send a transaction to the network saying as much. And then we can create this graph of who trusts who. And what we'll find is that people that are launching Sybil attacks against this system are not trusted by anyone or anyone with any trust themselves. It's actually an example of the paid PageRank algorithm, slightly modified, if you know that from the early days of Google. So creates a web of trust, but needs people to essentially submit to it the edges of this graph. So send a transaction saying they trust someone, they trust another person, in order for the system to work. What they built was an astatine-based reward mechanism in order to achieve this. And one of the elegant sort of outcomes of this is like, hey, when people realize that they want their score to increase, they have to share their link, their verify me link, to other people on the PermaWeb. And the best way to do this is by pressing this little button that they added that says just tweet my link. And so people do. And then you can get into this really interesting loop where people being exposed to the mechanism leads to more people being exposed to the mechanism, creating greater interaction and obviously a greater web of trust, which is the real outcome that we're looking for. And if you want to get into it, and I think I would recommend that you do, you can look at modeling the likelihood that being at one node in this loop leads to being in the next node. So human exposed to the system, the astatine mechanism, there's like a 0.2 probability that they actually take part. And then once they're in the mechanism, there's a 0.3 probability that they're actually going to send that tweet. And then for each time that happens, we can expect that 2.3, just for example, random numbers, but for example, 2.3 new humans come along to the mechanism and are exposed to it in the first place. And then we can start to model, well, how effective is this system at bringing more people into this mechanism that we've created? And I would just say, then you can, once you have the statistics around this, you can start to hone each of the individual linkages, the weakest ones first, until you end up with a system that is self-perpetuating and self-growing. And that can be really, really effective. One of the interesting things we have in the Arweave community is that most people that are involved at this stage are really focused on the tech. They love the technology, as do I. But of course, this means that you're not necessarily a natural-born marketer. But you can, if you start to think about the problem like this and start to analyze it in this way and be really like, what would you say, focused on it in this format, then you can start to create something that's much better than traditional marketing anyway, just by treating the system as something you're engineering, not something that is marketing in the traditional sense. Very, very powerful. I would recommend that the more developer-focused, tech-focused developers in the ecosystem that are trying to build something that's bringing consumers in to actually use it, look at these mechanisms as a way of spreading the word and doing marketing for you. Okay, back to that reward function that we were discussing. I think it's 0.3 on the prior slide. So how do you calculate the rewards to give people for taking part? Well, one easy trick is to actually make the reward that each individual participant gets proportionate to the entire interaction that has happened during a day. For a reward period. So you can say the reward period is a day. You're going to give away some number of tokens on any given day. That could be static, or we'll talk about some other mechanisms you can use in the future. But just there's a reward per day or per time period. You can make the reward per person proportionate to their share of the interaction that's happened during that day. And what this allows you to do is it allows you to budget. So there's no way that the mechanism here will be runaway, if you will, and cost you much more than you'd expected, which can certainly happen if you, for example, just say, if you store 1 gigabyte, I will give you 1 R drive. Then it's very hard to budget for how much R drive you should put aside. But you can use this to sort of normalize it, if you will. It also means that people at the beginning are very highly rewarded. And that sounds bad, but it's not, because it turns out that when people are highly rewarded for taking part in a task, then they tell their friends. And then the spready part of the mechanism is even more effective. And that just brings more people to the mechanism, bringing the pricing down in that way that we described earlier, to be as efficient as possible. But of course, downside there, now the users are kind of competing against each other potentially, and that leaves people sometimes quite upset. So upsides and downsides to that approach. I think in general that it's worth it though, in most cases. The final part to consider here is this reward today component. So astatine will allow you to have a static reward. You can say, I'm giving out 100 tokens every day for 90 days, something like that. Or you can create an exponentially decaying curve. This is somewhere like the block reward in Bitcoin, essentially. Yeah, you can have an exponentially decaying curve, which allows you to have a fixed price for the entire reward, yet have the reward program run indefinitely. This can be quite elegant, and particularly because essentially what you're trying to do through this type of system is bootstrap usage. And as usage increases in general, depends on the token dynamics, but in general, the value of the token should also increase. And so while the reward is exponentially decaying, the value of the token is kind of exponentially increasing. And so still the value of the reward that you're giving out on any given day might actually increase. Arweave, of course, uses a similar system to this. It has an exponentially decaying block reward, inflation reward. And even though we're 3 years into this and it halves every year, the block reward right now is the highest it's ever been, just because of the increasing value of the network during the time that the program has been running. Okay, so that's a brief overview of mechanism design. I hope you guys all enjoyed. There's going to be lots of questions you might have. You can always find us on the Arweave Developer Discord server. If you want to get started making one of these things, it's actually quite simple. You just Google Astatine, the program that the Verto team made. They made it super easy to distribute profit-sharing tokens relative to engagement in some kind of task. You can define that in just like 10 lines of code or something like this, and execute that very, very easily and embed it in your application in the right way. What's harder is making sure that you're getting the mechanism right in the first place. So we're always here if you want to talk to us about it. Other than that, yeah, I guess we'll chat on GatherTown now.